Tire-derived aggregate, or TDA for short, is a cost-effective alternative in many civil engineering projects. Because TDA is a new material, it is important to understand that TDA has undergone rigorous scientific testing for its safe use in a variety of civil engineering applications. Ecologically friendly due to its very low impact on the environment, TDA can be used as a lightweight fill for embankments, retaining walls, and slope repairs, as permeable drainage material for landfills, septic systems, stormwater drainage systems, and as a vibration dampening material for light rail track. Think of TDA as a flexible form of gravel that has the benefits of being lightweight and more permeable than standard road gravel. Using TDA lessens the potential for overusing our natural resources, like mining for rock aggregate. And most of all, it reuses a waste product and keeps used tires out of landfills. Because of these benefits, tire-derived aggregate may perform better than rock aggregate, and in many locations may be less expensive. Additionally, TDA has a higher permeability factor. It is lighter than regular drain rock aggregate and has an increased potential for developing a biofilm, which is an effective water quality treatment method. Biofilms support a healthy population of bacteria and other organisms that provide a favorable biological treatment of organics in drainage water. It is important to note that TDA can be used in projects where water is a factor, either running through it or sometimes suffusing it for a time. After water comes into contact with TDA, it will often run off and leave the site, draining and commingling with other surface or groundwater sources. In order to assess any potential harm to the environment, this drainage water was subjected to extensive water quality testing. The results of the tests performed on TDA found that regulatory limits were not exceeded for any of the targeted toxic compounds. Some of this extensive, rigorous water quality testing on TDA was performed here at Humboldt State University in Arcata, California. Dr. Brad Finney is an environmental resource engineer. Professor Finney and his research assistant, Rochella Maeda, have tested TDA over the last several years. Both their laboratory and field tests have shown that TDA does not exceed the maximum contaminant levels, which are California's potable water regulatory standards.
I've been working with water and wastewater for 45 years. And my first reaction to the idea of using TDA in a water environment was almost repulsion. I can't imagine why anybody would want to do such a thing. Much to my surprise, I found the opposite to be true. In our current work, where we've been using TDA in a stormwater treatment setting, so we have water goes through the TDA into the soil and then joining a groundwater setting. The concentrations that we observe below the TDA layer, now it's after the stormwater passed through the TDA layer and then a foot of soil below that, were always below what went into it from the stormwater. So it provided better treatment than just having had that stormwater going directly to the receiving water. A properly designed system should pose no risk to the receiving water quality. We tested for 67 different VOCs and found 2, benzene and MIBK, both of them at concentrations below appropriate regulatory standards. I have not found a single piece of data that I've collected that would indicate that there's any environmental risk associated with the use of TDA. There simply is not any concentration issues with any of the leachate compounds that would pose any risk to public health. It has incredibly useful engineering properties. We should be using it.
Dr. Patrick Fox built a large machine to test the stress capabilities of TDA here at the University of California, San Diego. His findings prove TDA possesses superior stress capabilities compared to standard road fill materials.
The direct shear machine here at UCSD is the largest of its kind in the world. It measures 10 feet long by 6 feet high by 4 feet wide. The test results today were very significant because for the first time we were able to measure the full stress strain curve for the TDA material. In today's test we had 14,700 pounds acting down on the TDA, and it required over 17,000 pounds to tear it apart laterally. What that actually tells us is that the TDA is a very strong material compared to natural soil, and therefore is more desirable for construction. One interesting property of TDA is that it has an internal reinforcement due to the fibrous nature of the particles. Because TDA is made of rubber pieces, it has exceptional properties with regard to damping vibrations. These vibrations might come from a passing train, for example, or passing traffic on a highway, or from an earthquake. Those rubber pieces are elastic, spongy, they're soft, they absorb vibration very well, much better than natural soils.
CalRecycle has partnered with UC Davis and UC San Diego to evaluate the effectiveness of TDA as a backfill during earthquakes. This enormous research project has shown that TDA can withstand a jolt exponentially greater than the 1994 Northridge earthquake in California. UCSD houses the largest shake table in the world. It measures over 35 feet long, 22 feet wide, and 15 feet deep. It can hold up to 4 million pounds. It has the ability to amplify the force exerted by a very large earthquake by 200%. This test involved comparing the performance of a retaining wall using standard soil backfill material with a tire-derived aggregate backfill material when subjected to earthquake forces. Dr. Don Chang and Professor Il-Sang An, who are both structural engineers from UC Davis, conducted this research testing. Here at the UCSD shake table site, they placed a large concrete retaining wall inside this earthquake shake table. Many sensors and testing devices were then sealed inside the wall to record measurements during the test. Tire-derived aggregate was then added, and more sensors were embedded in and around the TDA. A geotextile fabric and 2 feet of soil were then added to the mix. This procedure replicates and matches the state construction standards of retaining walls built near highways and under bridge embankments across California. Huge underground actuators then simulate an earthquake event by creating a tremendous shaking condition. They generated a force of 6.7, the same magnitude as the Northridge earthquake. Shortly after this test, another force was created that was 100% times stronger than the first one. Within several minutes, a third simulated quake was generated by 200% times the shake and shock value of the original 1994 Northridge earthquake in Los Angeles, California. The results were very clear. When TDA was used as a backfill for retaining walls, it held up much better than just regular soil, the material that is normally used for this purpose. These tests prove that TDA is a reliable and safe alternative to a conventional soil backfill that meets earthquake safety standards. BART, the Regional Bay Area Rapid Transit System, also understands the importance of the test data. They now use TDA for earthquake protection underneath their tracks that lie near the major and seismically active Hayward Fault in Fremont, California.
It's a place where the Hayward Fault not just simply ruptures occasionally, but actually creeps constantly. So everything in our design, our track form, has to be flexible and accommodate that. TDA offers a uniquely flexible set of attributes and allows us to have a track form that will deal with all this constant movement without requiring maintenance activity.
Tire-derived aggregate is now a proven alternative to the more traditional use of gravel. It has superior performance compared to conventional construction materials when tested as a backfill subjected to earthquake loads and when used as drainage material. It also has the added benefit of being environmentally friendly. TDA does not release unhealthy contaminants into drainage water that exceed California water quality standards. TDA a smart solution that saves money and can be used safely all over California.